This takes me more to grasp.
Okay, so we're looking at a quadratic relation in the form y equals x squared plus bx plus c. And the first thing we want to do is factor this so that we can find the zeros of the relation. So what we're trying to do first is find the zeros, okay? So we have to factor. And we know that the zeros are also known as the x-intercepts. The reason they're called zeros is because what happens when something intercepts the x-axis? This value, which value is 0? What value will be 0 if it's going to hit the x-axis?
It's going to be under, on the...
So y has to be equal to 0. For example, let's say this was located at 1, 0, and let's say this was at 5, 0. The y value is always 0. Okay, that's why they're called the zeros of the relation.
Yeah.
Okay, so the first thing we want to do is factor. So we're looking for two things that multiply together to give us c, which in this case is 10. Okay, two things that multiply together to give us positive 10, and that add up to negative 11, and we just listed all of them. And what did you find was the answer? Negative 1 and negative 10,
Yeah.
and we know that negative 1 plus negative 10 equals negative 11. Good. So these are our factors. Okay, so we're going to write this. The first thing we want to do is factor this. So let's write it in factored form. Y equals, and then we know
you
that...
have to have the y
Yeah.
in front of them. Like that?
Yeah, so we have x minus 1 and x minus 10. So that's in factored form.
Yeah.
Okay, but the first question says find the zeros. Well, we just talked about this. If y is 0...
How do you know to make one of them?
Okay, so if y is 0, then we know that the value of x will be the x-intercept. Okay, I just made these numbers up before. It doesn't relate to the equation, so I'm going to erase that. Okay, that was just as an example. But we know that if y is 0, so x minus 1 is equal to 0, right? And x minus 10 is equal to 0. When y is 0, when the y value is 0, what's the x value? What does x become? So if x take away 1 is equal to 0, well, if we bring this to the other side, what does it become? X equals, bring it to the other side.
It's going to be have 1 over there?
Yeah, it's going to be positive 1.
Yeah.
So when y is 0, x is 1. And when y is 0, x is also, what happens here? Bring it to the other side.
It's going to become 10.
Positive 10. Excellent.
10. So what you did was...
Now that we know the two x-intercepts, we can plot those 2 points on the graph. So we know that the parabola will intercept at positive 1 and 10. Actually, I'm just going to have to change the numbers on this grid. Since this is the x-axis, it's going to intercept at positive 1 and positive 10, right? Now,
So that's these.
right, those are the x-intercepts. Now we're trying to find the axis of symmetry next. Well, we know that an axis of symmetry runs halfway through a parabola. So it's going to go directly in the middle of these 2 points, right?
Yeah.
Well, so we want to find the middle of 1 and 10. So we want to find what's in between them. So if we actually add 1 plus 10, how do you find halfway between two numbers? 1 plus 10 is 11. Yeah, we divide by 2 to find half.
Oh, yes. Yeah,
Okay, so 11 divided by 2.
2 would make equal half, right?
Right, exactly. 5.5. So we can draw an imaginary line here. 5.5. Now it's kind of hard to see on here.
Yeah.
Oops, sorry. Well,
Oh,
you
yeah,
get it. Yeah.
yeah.
And this looks right. This is halfway between our first x-intercept and our second x-intercept. So the way you would do it to find the axis of symmetry is add the two x-intercepts together and divide by 2, and that will give you your axis of symmetry. So we'll take notes on that. Using the same quadratic relation, we now need to find the vertex. So we know that the vertex is the point where the parabola changes direction, right? It goes from increasing to decreasing. It's either going to be at the very bottom of the parabola or the very top. Now, when we looked at the original equation of this parabola, it was y equals x squared minus 11x plus 10. What number can we assume is in front of x squared? What number?
1.
Good. That's our a value, right?
Yeah.
If a is positive,
Yeah.
how does a parabola open?
It's going to go up.
Like this. Good.
It's going to be minimum.
Good. It's going to open up and it's going to have a minimum value.
Yeah.
If a is a negative, we'll put these with our notes. If a is negative, it's going to open it down
It's gonna be max.
Good. So that's what you're talking about before, max and min.
I didn't get the.
Well, looking at this equation, it's positive. So we know that the parabola is going to open up. So
min.
I'm just going to draw a little sketch here, but then I'm going to erase it because we have to actually figure out where the vertex is. It's going to look something like this, but we don't know where that vertex is, right? So let me delete that.
Yeah.
We have to figure out where is the vertex going to be? Where is it going to basically change direction? Okay? Now, what do you notice about the axis of symmetry? This is our axis of symmetry. What do you think it has in connection to the vertex? Know that the axis of symmetry runs right through the vertex. So because you know the axis of symmetry, which was 5.5, that's actually equal to the x value of the vertex, okay? The vertex is going to be somewhere, if we were to plot it on the graph, it's going to be at, we're going to go across to 5.5 and down to something. We just need to know the y value. Right. So the vertex is a coordinate. We know that it's going to be located at 5.5 and something, right?
Yeah.
So we need to figure out that something. Once you know the axis of symmetry, you know the x value of the vertex. Okay?
So that I make it that you put.
So in order to find the y value, we're going to use the original equation. Now, we know the x value
Yeah.
is 5.5. We're just going to solve for y. So y equals, well, instead of writing x, I'm going to put 5.5 because that was my axis of symmetry. The equation is x squared, so 5.5 squared minus 11 times 5.5 times x, that's our x value, and then plus 10. So all we really need to do now is just solve for y. So follow BEDMAS. What's 5.5 squared? Yep. So 30.25 minus what's 11 times 5.5 is 60.5 plus 10. Let's keep simplifying. When we simplify this, we get y equals negative 20.25. Okay? So therefore, what we were trying to find was the vertex. Therefore, the vertex is located at 5.5, right? Across 5.5 and down, we can't fit it on this graph, but it's going to go all the way down to negative 20.25. So we'll look at what that, I'll give an example of what that looks like. Just to show you what the graph looks like. This was the original equation. I'm just using a graphing calculator. The x-intercepts were at 1. For some reason the numbers disappeared here, but it was at 1 and 10, okay? That's 17 right there. And the axis of symmetry was halfway between that at 5.5. And so this is the axis of symmetry. And the vertex was located at 5.5 and negative 20.5. And there's your parabola. And you can see it, it opens up.
Myself to find y value.
This has a minimum value, okay? What is the minimum value? What's the lowest point on this graph? Where did this graph end?
20.25.
Right, negative 20.5. So
it's not point.
yeah. Oh, sorry, I wrote it wrong. 0.25. You're right. Okay, so if they ask you for the minimum value is the y value of the vertex because it's the lowest point.
So this is the y value.
Made with Doodlecast Pro.